In this video, we are going to talk about expansion of substances. Under expansion of substances, we're going to see expansion of solids. Under expansion of solids, we are going to see linear expansion of solids, areal expansion of solids, and volume expansion of solids. Let's dive in with linear expansion of solids. Consider a wire of length L. This is a wire, just a cylindrical wire. It has a length of L at a temperature of T naught at the first temperature. When the temperature increases, when it is heated, it's gonna get a certain increase in change in length. It's gonna increase its length. So the whole is its length at the final temperature T final. And due to the change in temperature, you get a certain change in length. Now, what are the major factors that affect the change in length you get due to heating? Now, activities show that the change in length due to heating, delta L, the change in length is directly proportional to the length at the colder temperature. Meaning, as the change in length increases, as its colder temperature length is increased. They are directly proportional. The other factor is this change in length is also proportional to the change in temperature. So this implies the change in length, which is basically is equal to the length at the hotter temperature minus the length at the colder temperature, is increasing with two things. One is the change in the length at lower temperature, and the other is the change in temperature we brought. Meaning, the change in length has to be proportional to the product of these two factors. The length at the colder temperature times the change in temperature. Therefore, this change in length is equal to a constant times the length at the colder temperature times the change in temperature. But the constant of proportionality is denoted by alpha. It is coefficient of linear expansion, something related to the nature of the material from which the object is made. So we have the change in length is proportional to the length at the change in length is equal to the coefficient of linear expansion alpha times the length at the colder temperature times the change in temperature. Remember, the change in temperature is the temperature hotter minus the temperature colder. And the change in length has two equations here. One is the length at the hotter minus the length at the colder temperature. Now, we have two expressions for the change in length. Remember, the change in length divided by the length at initial temperature times the change in temperature gonna give you this coefficient of linear expansion. So the unit for this is gonna be the dimension for temperature coefficient gonna be the ratio of the dimension for this to the dimension to these two things. But the change in length in SI unit system, the change in length is in meter over this one is in meter again. The length at the lower temperature is also in meter, and the change in temperature is measured in either Kelvin or degree Celsius. Whenever you measure change in temperature, you can use the degree Celsius or Kelvin interchangeably because they are the same in measuring change in temperature. So the unit for, or the dimension for alpha, coefficient of linear expansion, is 1 over degree Celsius, because meter cancels meter, meter times 1. Then this is the same as degree Celsius raised to 1, or we usually say alpha is per Kelvin or per Celsius. So how do we find the expression for the final length? So we have the change in length is equal to the length at the hotter minus the length at the colder. The same change in length is equal to the length at the colder times temperature coefficient times change in temperature. This is equal to the length at the hotter minus the length at the colder. Remember, this L note means the length at, it is the length at the hotter. It's the same as LC. So when you collect and write expression for the length at the colder, at the hotter, you're gonna get length at the colder times change in temperature times temperature coefficient plus the length at the colder again, gonna give you the length at the hotter. This means you have these two terms, but these two terms have the length at the colder common. So you do length at the colder times change in temperature times alpha plus LC length at the colder times 1 is equal to, this is equal to the length at the hotter. Now these two things are the same, I mean constant for the two expressions. So the length at the hotter temperature is equal to the length at the colder into alpha times the change in temperature plus 1. So this is the equation to write the length of some conductor after some temperature T. Remember, the length at some temperature, hotter temperature, is equal to the length at colder into 1 plus alpha into, usually we write this as 1 plus alpha delta T. So the change in temperature is the temperature at the hotter minus the temperature at the colder. This is the expression for the length of a wire as a function of temperature. Let us do this example. A wire made from aluminium has a length of 4 kilometers, 400,000 millimeter at 20 degrees Celsius. Calculate the change in length and its length at 70 degrees Celsius. Let's dive in. Solution. We are asked to calculate two things. One is the change in length is required. The second is the length at the hotter temperature is required. Now let's extract the givens. We have coefficient of expansion for aluminium is 2.3 times 10 to the power of minus 5 k to the power of minus 1. And we have the length at the colder temperature. It is 400,000 millimeter, meaning this is 4 times 10 to the power of 5 millimeter. And the temperature final, the hotter temperature is given, it is 70 degrees Celsius, and the colder temperature is also given, is 20 degrees Celsius. And from these two givens, the change in temperature is temperature hotter minus temperature colder, and it is 70 degrees Celsius minus 20 degrees Celsius. That's gonna give you 50 degrees Celsius. Okay, the formula for change in length is equal to the length at the colder temperature times coefficient of linear expansion of the material aluminium times the change in temperature. Now let's substitute. So this L is length at the colder temperature is 4 times 10 to the power of 5 millimeter times aluminium has 2.3 times 10 to the power of minus 5 k to the power of minus 1 times the Celsius is, the change in temperature is 50 degree Celsius. I told you degree Celsius and Kelvin are equal for changing lengths, for changing temperature. To measure changing temperature, we can use the changing temperature, the Celsius and the Kelvin interchangeably. All right, now let's simplify this. You can write this as 4 times 2.3 times, all right, okay, we have 2.3 times 10 to the power of minus 5 times 10 to the power of 5 times this 15 means 100 over 2. Yeah, you can write this 100 over 2 as the following. So you can do this as 4 times 2.3 times, so there is something wrong with this calculation here. So this is repeated, this is repeated 2 times. So this is 4 times 2.3 times 10 to the power of minus 15 from the expansion, and 10 to the power of 5, and this is times, all right, you can do 10 to the power of minus 5 times 10 to the power of 5 times 10 to the power of 2, because 100 is 10 to the power of 2 over 2. Okay, so you can simplify this as, okay, I can bring this over to here. So 10 to the power of minus 5, 10 to the power of minus 5 times 10 to the power of 5 is, or 10 to the power any number a to the power of n times a to the power of m is, you do a to the power of n plus m, you add the power. So here you can bring the 2 here, 4 times 2.3 over 2 times 10 to the power of minus 5 plus this 5 plus this 2. So this is the same as 2 times 2.6 is 2.3 is 4.6. 4.6 times 10 to the power of 2 millimeter. So this means when you multiply this by 100, you're gonna get 460 millimeter is the change in length is equal to. The second question asked you to calculate what is its length at the colder temperature. Since we have already the change in length, we can use a simple way. The change in length is the length at the hotter plus the length at the colder. Minus. So you can bring this one here. So this implies the change in length plus the length at the colder gonna give you the length at the hotter. So the length at the hotter is equal to the change in length is 460 millimeter plus the length at the initial temperature is 400,000 millimeter. So when you add, you get this as 400, then 460 millimeter. So this is its length at a temperature of 70 degrees Celsius.